Okay, so welcome to this next video. This is going to be quite a quick one. We're going to be talking about interpreting graphs and tables. So you've seen graphs all the time. You've probably seen tables a lot all over the shop, because the reason that is that statistics is an area of maths that you will always run into. Okay, and you essentially have to deal with it for the rest of your life. Statistics and data analysis happens all the time, a lot of time without people noticing that it's going on. Because it is just so ubiquitous, right? And graphs and tables are the most simple formats used to represent data. So we're going to be checking that out before we move into the hard yakka and actual mathematics and calculations with statistics. So this one's a quick video. We're just going to have a look at a couple of common types of graph. Right. First one here is we have a column graph, or sometimes they're called bar graph sometimes. Or a bar graph. Bar graph could be more so one that has horizontal lines rather than vertical lines. Anyway, with these ones here, essentially what you're doing is that you're looking, so for instance, we've got here a zombie apocalypse objects by usefulness. So charts and graphs always have a little heading like that. Not always so ridiculous as this one, but essentially you look at your different axes. So here we've got the tools: so shotgun, bladed weapon, water, people to help you, slower people to be used as bait. And so we look up to, so if we're looking at bladed weapon, we follow its column up, look across, and that we see that according to this graph, it is a mildly useful thing. And for instance, a shotgun is a must-have in a zombie apocalypse. Okay, so that's how we read our column graphs. You've probably done this a lot and had experience, not zombie apocalypses, bar graphs and column graphs. Okay, pie charts. So named such because they look like a piece of a pie that's been cut up into different pieces. Essentially, what they'll have is it's been cut up, and each of these different sections corresponds to a different percentage. So this is, about 25%, okay, of the whole. This is sort of a little over that, so this could be just over 25% here, okay, and all of this equates to about half of the full amount, okay, so that's sort of how we work out these pie charts. Pie chart is an interesting one. It's difficult to ascertain all of the information that's going on. They can be misread, they can be deliberately drawn up so that it will be misinterpreted. So it's not really one we'll use a lot, but you still need to be familiar with it. So as you can see here, that Rick Astley would never give you up just over 25% of the time, okay? And he would never make you cry, maybe about 15 or so percent. It would be this one here, okay? It's sort of colored differently to let you know which one's which, so you wouldn't have to write it all in there. Is sort of how those ones work. You've probably dealt with them heaps before. Okay, line graph. This is one where it's a line that shows a particular data set, and you again read the axes to figure out what's going on. So here, this is something called the black body radiation curve. Okay, and it describes at particular temperature. For instance, here, temperature of 5,550 Kelvin, which is about the temperature of our sun. How it, the intensity of the wavelength of light. So this is, as we see, we can look at, for an object that is 5,500 degrees, 5,500 Kelvin, which is about 5,300 degrees Celsius. If we look at light that is 500 nanometers in its wavelength, we're going to see an intensity of just over 800, okay, 820 maybe. And that is its energy density, and that's how we read these line graphs. So you essentially find what you want from this end, follow it up, see where you hit the line graph, go across, and there is corresponding reading. Okay, so that's how you organize those ones there. Scatter plot, it's actually looking a little dim. You might not be able to see that very well, but essentially this is a power in versus power out from one of our science experiments this term, and this is the power in and power out, and each of these dots corresponds to a particular measurement that was taken. You'll often see these done up for a particular science experiment that's been done, and so this means that at 50 watts in, we're getting that much out. 50 watts in, sorry, this is hertz. This is frequency. Frequency in. At 50 hertz, we're getting about 0.18 watts in power. Okay, and so that's how you read these. You've looked for your data point, and that sort of this shows what the values it corresponds to. Okay, sometimes you can do a little line like we've got here to sort of give you an idea of how things are working in it. Tables. Now, again, you've probably seen these heaps of times before. You read them in a similar way. That this, let's just say this data piece here of 93.5 means that you look this way to see what it corresponds to. Well, it's Chinese Hong Kong, and in 2005, the net enrollment in primary education as a percentage was 93.5. So you can see that 93.5% of primary school aged kids were enrolled in primary school in Hong Kong, and that's just how you read these tables. Now, this video may have seemed a little bit disjointed and weird, and that's because learning how to read tables is probably something you've done before, but I just want to show those just as a little introduction, and that's just to sort of kickstart this stats unit. So please come along with any questions, any ridiculous or silly charts or graphs that you may have found that we can all have a laugh at would be great. Otherwise, I hope you enjoyed the video. Thanks.